In Lesson 8, you're going to learn about the other laws of exponents. So far, you've learned the multiplying and adding. Today, you're going to work with division, what happens when your exponent's 0, and also what happens when your exponent is negative. So the next one is x to the a divided by x to the b equals x to the a minus b. So what that says is when you have a base divided by a base, you keep the base the same and you subtract the exponents. So the two examples I have are 5 to the third divided by 5 to the first. So this is really going to be 5 squared, because 3 minus 1 equals 2, and again my base stays the same. My base is 5 in this case. In the second example, x to the ninth divided by x to the fourth is going to be x to the fifth, because 9 minus 4 equals 5. X to the negative a is rewritten as 1 over x to the a. So what that means is when you have a negative exponent, you rewrite it as a fraction with 1 as the numerator and the base with a positive exponent as the denominator. So 2 to the negative third is going to be rewritten as 1 over 2 to the positive third, which can be simplified as 1 over 8, because 2 to the third is 8. X to the negative 5 is going to be rewritten as 1 over x to the fifth. Now it's important to know that if you had something that was positive, for example, if I had 3x to the negative 6, I would rewrite it as 3 over x to the positive 6, because all that needs to go in the denominator is simply just your base with the exponent that's negative. My 3 is positive, so instead of having a 1 over x to the 6th, it's a 3 over x to the 6th. That'll make more sense after you complete the next lesson. Here's some other exponent information. X to the 0 is always equal to 1, which means any number raised to the 0 power is always 1 except for 0, meaning if 0 was your x. So this is just something that's common knowledge that you kind of just have to know, but I want to make sure you understand as to why it works. So if you think about it, in 2 slides ago, you had the division and you subtract the exponents from that. So 3 minus 3 is really 0. So realistically in the example, it would just be 5 to the 0 power, because again 3 minus 3 is 0, which according to our rule equals 1. But I want to make sure you understand as to why it is 1. So 5 to the third is really 5 times 5 times 5 over 5 times 5 times 5. Now, looking at this, these cancel out and become a 1. These cancel out and become a 1. And these cancel out and become a 1. So I really have 1 times 1 times 1, which equals 1. So that's the proof as to why anything to the 0 power equals 1, because everything ends up canceling out and just becoming 1s. Again, you're going to work with this a lot more in the next lesson.